Good evening, and welcome to a gentle look at one of your body's most amazing systems. I'm so glad you chose to spend this quiet hour with me as we explore the complicated pathways that keep you alive every second of every day. If you're new here, and this is helping you relax, I'd love for you to join our community of curious people who love learning in the most relaxing way possible. And I'm always curious. Where in the world are you listening from tonight? Maybe you're in bed in Toronto, or maybe you're looking at the stars from a window in Melbourne. No matter where you are, take a moment to get comfortable because we're about to go on an interesting journey through your circulatory system. We'll be following the quiet, steady path that your blood takes through your body tonight. You have been living this story since before you were born, and it will continue until the day you die. As you read this, about 5 litres of blood are moving through 60,000 miles of blood vessels inside you. That's enough tubing to go around the earth more than twice, all coiled and folded up in your body. When you think about it, it's pretty amazing that you have a transportation network inside you that's more complicated than any highway system ever built. People often call the circulatory system the body's highway, but I like to think of it as something more natural and alive. Picture the root system of an old oak tree, which spreads out and divides, reaching into every corner of the rich soil. Your blood vessels branch out from big highways to tiny country lanes, making sure that every cell in your body gets the nutrients it needs and the waste it needs to be removed. Your circulatory system, on the other hand, is full of life and is powered by the best pump ever made: your heart. Your heart is about the size of your closed fist and is between your lungs. It weighs about 11 ounces, which is about the same as a can of soda, but it can do work that would wear out any machine. Your heart beats about 100,000 times a day. It pumps about 5 litres of blood through your body every minute. Your heart will have beaten more than 2.5 billion times by the time you turn 70. It will never take a coffee break, call in sick, or ask for overtime pay. You might never meet a more dedicated worker than this one. The way your heart is built is both simple and very complicated. Imagine a house with 4 rooms, 2 on the first floor and 2 on the second. The Latin word for entrance hall is atria, which is what the upstairs rooms are called. These are the chambers that receive blood after it has travelled through your body. The right atrium receives blood that has already given oxygen to your tissues and is now carrying carbon dioxide, which is a waste product of cellular activity. The left atrium gets blood that has just been oxygenated in your lungs. It is bright red and ready for another trip. The ventricles, which are the strong pumping rooms of your heart, are below these receiving chambers. The right ventricle sends blood that is tired and full of carbon dioxide on a short trip to your lungs to get fresh air. The left ventricle, which is strong and muscular, sends the newly oxygenated blood on its way through your whole body. This chamber works harder than any other part of your heart. It makes pressures that would make a garden hose jealous. The walls of these rooms tell a story of perfect engineering. Myocardium is the name for the heart muscle. It is different from all the other muscles in your body. It combines the strength of skeletal muscle with the endless endurance of smooth muscle to make a tissue that can contract strongly and rhythmically for decades without stopping. The muscle fibers are arranged in complicated spirals, which lets the heart wring out blood like a washcloth being twisted. This makes each contraction more effective. Heart valves, which are like locks in a canal system, keep blood from flowing in both directions between these chambers. The 3 delicate flaps of the tricuspid valve protect the opening from the right atrium to the right ventricle. Each flap is attached to small strings called chordae tendineae, which are then attached to small muscles called papillary muscles. These parts work together like a complicated puppet system to make sure the valve opens and closes at the right times. The pulmonary valve opens so that blood can flow to your lungs. This valve has 3 cup-shaped cusps that catch blood that is trying to flow backward and snap shut with amazing accuracy. The bicuspid or mitral valve, which has 2 graceful cusps, controls the flow of blood from the left atrium to the left ventricle on the left side. This valve is the strongest because it has to handle the highest pressures in your heart. And finally, the aortic valve, which is the entrance to the main highway in your body, opens and closes with each heartbeat to send blood on its way through the aorta. These valves are amazing pieces of biological engineering. They are made of thin, flexible tissue that reacts to changes in pressure with the same accuracy as a Swiss watch. The tissue is very strong. It can open and close more than 2 billion times in a person's lifetime without getting worn out. They open when there is a lot of pressure behind them. When the pressure changes, they snap shut, making the sound of your heartbeat, which is the sound of lub-dub. The lub is the sound of the ventricles contracting and the tricuspid and mitral valves closing. The dub sound is made when the pulmonary and aortic valves close and the ventricles relax. It's a percussion section that never misses a beat, and the rhythm section has been playing your own symphony since before you were born. The electrical system that keeps your heart beating is probably even more amazing than the mechanical pumping. The sinoatrial node is a small group of specialized cells in the right atrium that act as a built-in pacemaker for your heart. These cells make electrical impulses on their own about 70 times a minute, which is what makes your heart beat. The impulse spreads through both atria like ripples on a pond, making them all contract at the same time. The electrical signal then hits the atrioventricular node, where it stops for a short time. This gives the atria time to finish emptying before the ventricles start to contract strongly. The signal then travels quickly down specialized conducting fibers known as the bundle of His, spreading quickly through both ventricles to coordinate their contraction from the bottom up, pushing blood toward the exit valves. This electrical system can change its rhythm to fit what your body needs. When you work out, your sympathetic nervous system releases hormones that speed up the pacemaker. The parasympathetic nervous system slows it down while you sleep. Your heart also reacts to feelings. The rhythm of your heartbeat changes when you're excited, scared, or in love. Let's start our journey with a single drop of blood going back to your heart. This drop is like a little red taxi that just dropped off a package in your left big toe. Now it's full of carbon dioxide and other cellular waste. It's tired from working, but it's on its way home through the huge network of veins. The vena cava, one of the great veins, brings our drop into your right atrium. The superior vena cava brings blood from your head, arms, and upper chest. The inferior vena cava brings blood from your abdomen, pelvis, and legs. The right atrium is like a calm pool where blood that is coming back collects and waits. The walls are thin and can stretch to fit different amounts of blood that are coming back. As this chamber fills, the pressure slowly rises until it is higher than the pressure in the right ventricle below. When the tricuspid valve opens, our drop flows into the right ventricle like water through an open gate. The right ventricle is getting ready to do something. Its muscles start to tighten, building up pressure like a bellows getting ready to fan a fire. The tricuspid valve snaps shut behind our drop, so we can't go back now. The pressure keeps rising until it breaks through the pulmonary valve's resistance, which opens up quickly. Our drop is sent into the pulmonary artery, where it starts its short but important trip to the lungs. This trip to the lungs is called pulmonary circulation, and it's not as big of a deal as what's coming next. The pulmonary artery quickly splits into two branches, one for each lung. These branches keep splitting, just like your bronchial tubes do, until they are so small that our red blood cell drop has to squeeze through in a single file. The way the branches are arranged is based on math that maximizes flow and minimizes resistance. Each division makes vessels that are smaller on their own but have a larger total cross-sectional area than the parent vessel. This means that blood moves more slowly from larger to smaller vessels, which gives the important exchanges that happen in the capillaries more time to happen. Magic happens in the lungs. There are about 300 million tiny air sacs in your lungs. These are called alveoli. If you could spread out all of these sacs, they would cover an area about the size of a tennis court. All of them would fit in the space of your chest. A network of very fine capillaries surrounds each alveolus. This makes an interface between air and blood that is only about half a micrometer thick, which is thinner than the finest tissue paper. In these tiny spaces, our tired blood meets fresh oxygen from the air you've just breathed. The exchange that happens here is both simple and deep. The carbon dioxide that our drop has been carrying goes through the thin walls of the capillary and into the airspace of the alveolus. At the same time, oxygen molecules move in the opposite direction and attach to the hemoglobin in our red blood cells. It's like a dance that has been perfectly planned, with molecules switching partners at just the right time. The difference in gas concentration on either side of the membrane is what makes this exchange happen. Because there is more carbon dioxide in the blood than in the air, it naturally moves from blood to air. The air has more oxygen than the blood, so oxygen moves from the air to the blood. This simple idea, called diffusion, is what makes one of the most important things happen in your body. It's amazing how hemoglobin works. Each molecule has 4 leaves that look like a 4-leaf clover. An iron atom is in the middle of each leaf. This iron is what makes blood red and what makes it so good at holding on to oxygen. When oxygen binds to hemoglobin, the whole molecule changes shape a little bit, going from a dull purple red to a bright cherry red. This shape change also changes how hemoglobin works, making it easier for more oxygen molecules to bind. This is known as cooperative binding, and it makes loading oxygen in the lungs more efficient. Hemoglobin does more than just carry oxygen, though. It also helps move carbon dioxide, but in a more complicated way. Some carbon dioxide attaches directly to hemoglobin, but most of it changes into bicarbonate ions in the red blood cell and is then carried in the plasma. Hemoglobin also helps keep the pH of your blood stable by acting as a buffer that stops dangerous changes in acidity. The drop of blood has changed from venous blood to arterial blood. It is now fresh and full of oxygen. The blood that has just gotten oxygen flows from the capillaries into small vessels called venules and then into bigger pulmonary veins. These veins are strange because they carry oxygenated blood instead of deoxygenated blood. They take our refreshed drop back to the heart, specifically to the left atrium. This is the start of the second part of our trip. The left atrium gets blood like a reservoir, gets water from a mountain spring. The walls of this room are a little thicker than those of the right atrium because it has to deal with the slightly higher pressures of the systemic circulation. As it fills, the pressure rises until the mitral valve opens, letting our drop flow into the left ventricle. The walls of this chamber are 3 times thicker than those of the right ventricle, making it the heart's bodybuilder. It needs to be strong because it's about to send our drop on a trip that will take it to the tips of your fingers and toes. During systole, the left ventricle contracts with a lot of force, creating pressures that can reach 120 millimeters of mercury or more. To give you an idea of how much pressure this is, it is enough to squeeze a column of mercury that is 120 millimeters high, or about 4.5 inches. The mitral valve slams shut, and when the pressure is strong enough to push through the aortic valve's resistance, our drop is sent into the aorta with a lot of force. You can feel this pressure wave moving through your arteries with each heartbeat if you've ever felt your pulse. The aorta is the main road in your body. The widest part is about 1 inch across, which is about the size of a garden hose, and it's made to handle high pressure. There are 3 different layers in its walls. The intima, which is a smooth inner lining that cuts down on friction. The media, which is a thick middle layer of smooth muscle and elastic fibers. And the adventitia, which is a tough outer layer that holds everything together. The elastic fibers in the wall of the aorta are very important for how your circulatory system works. With each heartbeat, they stretch out and store energy, like a rubber band being pulled. These elastic fibers pull back between heartbeats when the heart is relaxing and filling up again. This pushes blood forward and keeps pressure up throughout the system. This elastic recoil is what keeps blood flowing smoothly, even when your heart is resting between beats. This is called the Windkessel effect, which is named after the air chambers that kept water flowing smoothly in old fire engines. There are many places our drop can go from the aorta. The coronary arteries are the first branches of the aorta. They curve back to bring blood to the heart muscle. It's kind of beautiful that the heart feeds itself first, even though it works so hard to pump blood to all the other organs. The heart muscle needs a lot of oxygen. It takes more oxygen from blood than any other tissue in your body. Our drop might take the next exit and go up through the carotid arteries to your brain. Even though your brain only makes up about 2% of your body weight, it needs about 20% of your heart's output. It needs a lot of glucose and oxygen all the time. Your brain works at full speed all the time, unlike other organs that can store energy or slow down their metabolism for a short time. This means that it needs a steady flow of blood to work properly. The blood vessels in your brain are unique because they are surrounded by the blood-brain barrier, a selective membrane that keeps harmful substances out while letting nutrients in. The cells that line the brain's capillaries are tightly joined, which creates a selective filter that keeps toxins out while letting in glucose, oxygen, and other important molecules. There are some amazing backup systems in the blood supply to your brain. The circle of Willis is a ring of arteries at the base of your brain that gives blood flow a different path if one of the main arteries gets blocked. This backup is very important because brain cells start to die within minutes if they don't get enough oxygen. Having more than one way for blood to flow is a good way to protect against stroke, or maybe our drop will go a different way, down the descending aorta toward your abdominal organs. The celiac axis and superior mesenteric artery make up the first big branch that goes to your stomach, small intestine, liver, and pancreas. After you eat, these organs get more blood flow to help with digestion and absorption. Your kidneys need a lot of blood flow. They get about 25% of the blood that your heart pumps, even though they only make up about 1% of your body weight. They filter your blood and keep the chemicals in your body in the right balance so you can live. There are about 1 million tiny filtering units in each kidney. These are called nephrons, and they each have their own blood supply, which is a group of capillaries called a glomerulus. The kidneys do more than just filter waste. They also control blood pressure, make hormones that help make red blood cells, and keep the right amount of water and electrolytes in your body. You can change how much blood flows through your kidneys based on what your body needs. Hormones cause the blood vessels in the kidneys to narrow a little when you're dehydrated. This slows down filtration and keeps water in the body. Let's say our drop goes to your liver, which gets blood from 2 places. Most organs get oxygen-rich blood from arteries and send oxygen-poor blood back through veins. Your liver is different though. Like other organs, it gets oxygen-rich blood through the hepatic artery, but it also gets blood full of nutrients from your digestive organs through the portal vein. This means that the nutrients from your last meal go straight to your liver, where they are processed and packaged for delivery to the rest of your body. The liver has 2 blood supplies because it serves 2 purposes. It is a metabolic factory and a detoxification center. The hepatic artery brings oxygen to the liver, which needs it for its energy-intensive processes. The portal vein brings the liver the raw materials it needs to do its job, such as nutrients, toxins, and other absorbed substances. The liver is an incredibly complicated chemical factory. It does more than 500 different things, like making proteins that help your blood clot and breaking down toxins that could hurt you. As our drop of blood goes through the liver's sinusoids, which are special capillaries that let blood and liver cells get close to each other, it might pick up proteins that have just been made, drop off toxins to be processed, or pick up glucose that has been changed from stored glycogen. It's amazing how well the liver can heal itself. It can grow back completely from as little as 25% of its original size. This ability to regenerate shows how important the liver is. Your body can't live without it. So evolution has given us this amazing backup system. Our drop keeps going from the liver, maybe going through the femoral artery to the muscles in your legs. These muscles have been working hard to break down glucose and make carbon dioxide and other waste products if you've been walking or working out. The change from big arteries to small capillaries happens slowly, through smaller vessels called arterioles. Your circulatory system's arterioles are like traffic cops. These tiny blood vessels, which you can't see with the naked eye, but are very important for circulation, can open and close to control blood flow to different tissues. Smooth muscle cells line them and respond to nerve impulses, hormones, and local chemical messengers to change the flow of blood as needed. The capillaries in your muscles are set up in networks that can get bigger or smaller, depending on how much blood they need. When you rest, a lot of these capillaries are closed, and blood moves through the tissue more directly through thoroughfare channels. But when your muscles need more oxygen and nutrients, these capillary beds open up wide, letting a lot more blood flow. During intense exercise, this can make blood flow to muscles more than 20 times faster. The exchange that happens in muscle capillaries is the opposite of what happens in your lungs. The oxygen in our blood goes to muscle cells, where it will be used in the mitochondria, which are like cellular furnaces, to burn glucose and make energy. The process is very effective. It captures about 40% of the energy in glucose as usable cellular energy, and the rest turns into heat that keeps your body temperature stable. Carbon dioxide and other waste products leave the muscle cells and enter our blood. As arterial blood gives up its oxygen, it slowly changes from bright red to darker purple red. But this change in colour only tells part of the story. The blood also picks up metabolic acids that could be harmful if they build up, lactate from hard muscle work, and other cellular waste products. The walls of the capillaries are very thin, only one cell thick, to make these exchanges easier. But they're not just barriers that don't do anything. The cells that line capillaries actively control what goes through them by opening and closing gaps between cells to control the movement of bigger molecules. They can also make things that change the size of blood vessels, blood clotting, and inflammation. As our drop moves through the capillary networks, it eventually enters small vessels called venules, which are then followed by bigger veins. The arterial system and the venous system are very different from each other. Arteries are thick-walled and muscular, which makes them good at handling high pressure. Veins, on the other hand, are thin-walled and flexible, which makes them good at handling large amounts of blood at low pressure. About 60% of your blood volume is in your veins at any given time. These veins act as a reservoir that can be moved when needed. This venous reservoir is very important when you are under stress or lose blood. For example, when you give blood, your body quickly moves blood from this venous pool to keep blood flowing to important organs. Without you even realizing it, the veins can contract slightly to make less room for blood and push more blood back toward the heart. Veins have a tough job, especially the ones in your legs. They have to move blood up against gravity. They have one-way valves, which work like locks in a canal system to make this happen. These valves let blood flow toward your heart, but not back toward your body. The valves are fragile structures made up of two cup-shaped leaflets that come together in the middle when blood tries to flow back. The muscles in your legs help squeeze the veins when you walk, which pushes blood up from one valve to the next. This muscle pump is so strong that it can make pressures that are higher than those made by your heart. This is why sitting or standing for a long time can be bad for you. Without muscle contractions to help pump blood back to your heart, it can pool in your legs, making them swell and hurt. There are also some interesting changes in the venous system. The walls of the veins in your legs are thick and muscular, and they can contract to help push blood up. The veins in your stomach make a network that can stretch to hold a lot of blood when necessary. The veins that drain your brain don't have any valves. Instead, they rely on the negative pressure created by breathing and the pumping action of cerebrospinal fluid. Our tired drop of blood, which is now full of carbon dioxide and waste, slowly makes its way back to your heart through veins that get bigger and bigger. The blood moves more slowly through the veins than through the arteries. This gives the blood more time to exchange heat and lets the body deal with and buffer the waste products. The superior and inferior vena cava are the biggest of these veins. They send blood back to the right atrium where our journey started. The superior vena cava takes blood from your head, neck, arms, and upper chest, while the inferior vena cava takes blood from the rest of your body. These big veins are like rivers that form when many smaller streams come together. Each stream carries blood from a different part of your body. It usually takes about a minute for our drop to go all the way around your body. But this is only one of the many ways to get there. Your circulatory system is a complex network with lots of branching paths, not just a simple loop. Blood can take shortcuts through different connections between vessels, spend different amounts of time in different organs, or even skip some organs altogether in some situations. The story goes on. This 1-minute trip will happen again and again, with some changes for the rest of your life. Sometimes our drop might go through your kidneys to get filtered more. After a meal, it might spend more time in your digestive organs at other times to help move the nutrients it has just absorbed. If you have an infection, it might stay in your lymph nodes or spleen, where immune cells are fighting off the germs. Your circulatory system is very flexible. When you stand up quickly, sensors in your blood vessels notice the sudden change in pressure and tell your heart to beat faster and your vessels to tighten a little bit to keep blood flowing to your brain. This reaction happens in a matter of seconds, so you won't faint when you get up quickly. The changes are even bigger when you work out. Your heart rate can go from 60 to 70 beats per minute at rest to 150 or more beats per minute. Blood is sent to your working muscles instead of your less active organs. You take deeper breaths to get more oxygen. The blood vessels in your skin open up to help cool down the heat that your muscles make. Your nervous and endocrine systems work together to make all of these changes happen so that your body can handle more physical activity. When you're cold, your body tries to keep heat by sending less blood to your skin. This is why your hands and feet get cold first. When you're hot, the opposite happens. Blood flow to your skin increases, and you might see that your face and hands are getting red. Your body temperature stays pretty much the same, even when the weather is really bad. Angiogenesis is the process by which your body can make new blood vessels when it needs to. When a blood vessel gets blocked, smaller vessels can slowly grow larger to let blood flow through them. New capillaries grow as a result of chemical signals from tissues that need more blood. It's like your blood vessels making their own detours around traffic jams. The human body is very strong because it can adapt to many different situations. If the collateral circulation has had time to grow, people can live with big blockages in their main arteries. The body's ability to move blood around obstacles shows how redundant the system is. Blood is much more than just a fluid that moves things around. It's a complicated tissue in liquid form that carries hormones that control activities in your body, immune cells that protect you from disease, and platelets that can quickly seal any leaks in the system. Your blood also serves as a communication network, sending chemical signals from one organ to another. The makeup of blood is very carefully controlled. The liquid part is about 55% plasma, and the cellular parts make up about 45%. The hematocrit is the ratio of blood cells to plasma. It can change a little depending on your health, where you live, and how active you are. For example, when you are at a high altitude, your body makes more red blood cells to make up for the fact that the air has less oxygen. Erythrocytes, or red blood cells, make up the vast majority of the cells in blood. The cells in the human body that are unique are the ones that don't have a nucleus. They have given up their cellular headquarters so that hemoglobin can have more room. This gives them their unique biconcave disc shape, which has the most surface area for gas exchange and lets them squeeze through the smallest capillaries. Your spleen will recycle a red blood cell after it has made this trip through your circulatory system about 3,000 times. Red blood cells only live for about 120 days, so your bone marrow has to keep making new ones to replace the ones that die. Erythropoiesis is the name of this process, and it makes about 2 million new red blood cells every second. Leukocytes, or white blood cells, are just as important as red blood cells, even though there are fewer of them. They're like the police for your body, patrolling your blood and tissues to look for signs of invasion or problems inside. There are many kinds of white blood cells, and each one has a different job. Neutrophils are the immune system's first line of defense. They're like the police officers who patrol your blood and are always ready to respond to an injury or infection. They can get to trouble spots by squeezing through the walls of capillaries and crawling through tissues. Once they get there, they eat and kill bacteria and other threats. B cells, which make antibodies, and T cells, which coordinate immune responses and attack infected cells directly, are both types of lymphocytes. These cells have amazing memories. Once they have seen a threat, they can recognize it again years later and respond quickly. This is what makes us immune and why vaccines work. Monocytes are the big machines that make your immune system work. They can change into macrophages, which are big cells that can eat and digest cellular waste, dead cells, and different types of pathogens. They're especially important for cleaning up after injuries and infections. Eosinophils and basophils are types of white blood cells that help fight off allergies and parasitic infections. Basophils release histamine and other chemicals that cause allergic reactions, while eosinophils are especially good at fighting parasitic worms. Platelets, also called thrombocytes, are the cells that fix things in your circulatory system when they break down. These tiny pieces of cells usually move through your blood without any problems, but when they hit damaged blood vessel walls, they spring into action. They stick to the wound and to each other, making a plug that stops the bleeding. Platelets do more than just fill in holes, though. They also let out chemicals that start a chain reaction that makes fibrin, which are protein fibers that weave together to make a clot. There are more than a dozen different proteins that work together in this process, which is called coagulation. It's so complicated that messing up any step can cause bleeding problems or, on the other hand, too much clotting. Plasma is the liquid part of your blood. It is 90% water, but the other 10% is made up of hundreds of different dissolved substances. Proteins keep blood at the right thickness and osmotic pressure, which stops fluids from leaking out of blood vessels and into tissues. Albumin is the most common of these proteins. It acts like tiny sponges that hold water in the blood. Your cells get their energy from glucose. Hormones, especially insulin and glucagon, carefully control how much glucose is in your blood. After you eat, your blood sugar levels go up because your body absorbs nutrients from your digestive tract. Insulin tells cells to take in glucose, and the liver turns extra glucose into glycogen so it can be stored. Glucagon tells the liver to break down stored glycogen and release glucose back into the bloodstream when blood sugar levels start to drop between meals. This delicate balance makes sure that your cells always have fuel even when you aren't eating. Hormones travel through your blood to get to the organs they need to work on. These chemical messengers control everything that happens in your body, from the quick reactions of adrenaline to the slow, long-term effects of growth hormone. Hormones are usually only present in small amounts in blood, but they can have big effects. Like security guards, antibodies patrol your bloodstream looking for certain threats that they have been trained to spot. These Y-shaped proteins can stick to bacteria, viruses, and other foreign things, marking them for death by other parts of your immune system. Waste products from cellular metabolism also move through your blood to organs that can get rid of them. You breathe out carbon dioxide through your lungs. Your kidneys get rid of urea and other nitrogen-containing wastes by making urine. The liver breaks down or gets rid of a lot of toxins. Another important job of your circulatory system is to keep your body temperature stable. Your blood takes in heat from your liver and muscles and spreads it throughout your body. Your core body temperature stays pretty stable, only changing a little bit even when the temperature and activity levels around you change a lot. When it's too hot, the blood vessels in your skin open up, letting more warm blood flow to the surface where it can cool off. You might also start to sweat, and as the sweat dries, it takes more heat with it. When you're cold, the blood vessels in your skin tighten, keeping warm blood in your core where it's needed most. You might also start to shake, which makes heat by making your muscles contract. The hypothalamus, a part of your brain, controls this temperature regulation automatically. This area works like a thermostat, keeping an eye on your body temperature all the time and making changes to keep it in the narrow range that is best for your body to work. Your circulatory system is also important for keeping the chemicals in your body, fluids, in balance. The pH of blood must stay within a very small range. Even small changes can be deadly. Your blood has buffer systems that keep acids and bases from changing the pH in a dangerous way. The bicarbonate buffer system is very important. When you exercise, your cells make acid. Bicarbonate ions in your blood neutralize the acid. When your blood gets too basic, carbonic acid gives off hydrogen ions to bring things back into balance. This system works with your lungs and kidneys to keep the pH level where it should be. Your circulatory system moves ions, which are electrically charged particles, from places where there are too many to places where there are not enough. Potassium and sodium are very important for how muscles and nerves work. Calcium is important for blood clotting and keeping bones healthy. Iron is necessary for the transport of oxygen. For good health, these minerals need to be in the right amounts. The health of your circulatory system has an effect on every part of your health. When blood flow is good, you feel good, your mind is clear, and your body works well. If your circulation isn't working right, you might feel tired, have trouble concentrating, or notice that wounds take a long time to heal. One important sign of a healthy circulatory system is blood pressure. The systolic pressure, which is the higher number, shows how much pressure there is when your heart beats. The lower number, or diastolic pressure, shows the pressure when your heart is at rest. Both numbers are important, and things you do in your daily life can affect both of them. Hypertension, or high blood pressure, makes your heart work harder and can hurt the walls of blood vessels over time. Low blood pressure can cause organs, especially the brain, to not get enough blood flow. The best blood pressure for each person is different, but most experts agree that lower is usually better, as long as it is not too low. Your circulatory system gets a lot of benefits from exercise. Working out regularly makes your heart muscle stronger and more effective. A healthy heart can pump more blood with each beat, so it can beat slower while still meeting your body's needs. This is why athletes' resting heart rates are often in the 50s or even 40s. Your blood vessels also get healthier when you work out. Exercise makes your body make more nitric oxide, which helps blood vessels relax and get bigger. It can also help your muscles grow new capillaries, which makes it easier for oxygen to get to them and waste to leave them. What kind of exercise you do is important. Aerobic exercise, which includes activities that make your heart beat faster for long periods of time, is the best for your heart health. This includes swimming, jogging, walking, biking, and dancing. Resistance training, like lifting weights, is good for your heart in different ways. Even a little bit of exercise can be very good for you. Walking quickly for 30 minutes most days of the week can lower your risk of heart disease, stroke, and a lot of other health problems. The most important thing is to be consistent. Moderate exercise on a regular basis is better than intense exercise every now and then. The foods you eat also have a direct effect on your circulatory system. Your blood carries the nutrients from the food you eat to every cell in your body. It also carries the effects of bad food choices. Foods high in saturated and trans fats can make fatty deposits build up in your arteries. On the other hand, foods high in antioxidants can help keep your blood vessels safe from damage. Fish, walnuts, and flax seeds are all good sources of omega-3 fatty acids, which have anti-inflammatory effects that are good for your circulatory system. They can help lower blood pressure, make blood vessel walls work better, and stop blood from clotting. These healthy fats are absorbed by the cell membranes in your body, which makes them more flexible and useful. Fruits and vegetables have antioxidants that protect your blood vessels from damage caused by free radicals. Your body makes these unstable molecules on its own, but they can hurt you if they aren't neutralized. Vitamins C and E, as well as flavonoids and carotenoids, are all good for your blood vessels. Whole grains, fruits and vegetables all have fiber in them, which can help lower cholesterol levels in your blood. Soluble fiber sticks to cholesterol in your digestive tract, which stops it from being absorbed. This makes your liver use up cholesterol that it has stored to make bile acids, which lowers the amount of cholesterol in your blood. Many people have high blood pressure because they eat too much salt. When you eat too much sodium, your kidneys hold on to more water to dilute it, which raises blood volume and pressure. Cutting back on salt can help lower blood pressure, especially in people who are sensitive to salt. Stress also has a big effect on your circulation. When you're under a lot of stress for a long time, your sympathetic nervous system stays active, which can cause your blood pressure and heart rate to stay high. Stress hormones like cortisol and adrenaline make blood vessels narrow and make the heart work harder. This long-term activation can lead to heart disease over time. Finding ways to relax, like meditation, deep breathing, or just making sure you get enough sleep, can have a positive effect on your heart health. When you relax, your parasympathetic nervous system takes over. This slows your heart rate, lowers your blood pressure, and makes your circulatory system work better. Sleep is very important for the health of your heart and blood vessels. When you are in deep sleep, your heart rate and blood pressure drop naturally. This gives your cardiovascular system a chance to rest and heal. Growth hormone, which is mostly released while you sleep, helps keep blood vessel walls strong and repair them. People who don't get enough sleep on a regular basis are more likely to have heart disease, strokes, and high blood pressure. As we get older, our circulatory system has to deal with new problems. As time goes on, blood vessels naturally lose some of their elasticity. This is called arteriosclerosis. The walls of arteries get thicker and stiffer, which makes it harder for them to expand and contract with each heartbeat. This makes the heart work harder, which can raise blood pressure. As we get older, the heart muscle itself may change, sometimes getting a little thicker and less effective. The maximum heart rate goes down as you get older, but this doesn't always make it harder to do everyday things. The heart's electrical system can become irregular, but most of these changes are not dangerous. But a lot of the changes we think of as signs of aging are really caused by how we live, not by getting older. People who stay active, eat well, and handle stress well often have very healthy hearts and blood vessels even when they are older. Successful aging means keeping your heart healthy by making smart choices about how you live. Modern medicine has come up with some amazing ways to treat problems with the circulatory system. Surgeons can put in new heart valves made of strong materials or biological tissue from other species to replace ones that are broken. They can use blood vessels from other parts of the patient's body to get around blocked arteries. This makes new paths for blood to flow around damaged areas. Surgeons can even move entire hearts in the most serious cases. In 1967, the first human heart transplant was done. At first, the results were not good, but better surgical methods and anti-rejection drugs have made heart transplantation a good option for people with end-stage heart failure. Drugs can help keep blood pressure in check, stop blood clots from forming, and help the heart work better. ACE inhibitors and ARBs help blood vessels relax, which makes the heart work less. Beta blockers lower blood pressure and slow the heart rate. Statins can lower cholesterol levels and may also help blood vessels by reducing inflammation. Antiplatelet drugs, such as aspirin, can help stop blood clots that could lead to strokes or heart attacks. But the choices you make every day may be the best medicine for your circulatory system. The foods you eat, how much you move, how you deal with stress, and how well you sleep all have a big effect on your heart health. You have complete control over these choices, and you can see their effects fairly quickly. The arteries and veins are the main highways of your circulation, but that's not the end of the story. The lymphatic system is a whole other circulation system that works closely with your blood circulation. Blood flows in a closed loop, but lymphatic fluid only flows in one direction, from your tissues back to your bloodstream. The lymphatic system starts with tiny blind-ended vessels in your tissues that pick up extra fluid that has leaked out of blood capillaries. Lymph is a type of fluid that is like blood plasma, but has fewer proteins in it. The lymphatic vessels slowly come together to form bigger collectors, which then empty into big veins near your heart. Lymphatic vessels don't have a central pump like blood vessels do. Instead, they move lymph along by using the contraction of nearby muscles, the pulsation of nearby arteries, and one-way valves. The walls of the vessels have smooth muscle in them that contracts in a rhythm, which helps move lymph forward. Lymph nodes are small, bean-shaped organs that are spread out through your lymphatic system. They act like security checkpoints where immune cells check the fluid for signs of infection or other problems. When you have an infection, these nodes often get bigger because immune cells are multiplying to fight the germs. Your body's early warning system works with your circulatory system to keep you healthy. The lymphatic system is also very important for taking in fat. Lacteals are special lymphatic vessels in your small intestine that take in fats and fat-soluble vitamins from food. These fats are too big to go straight into blood capillaries, so they go through the lymphatic system first, and then into the bloodstream near your heart. The spleen, which is often called the body's largest lymph node, filters blood in the same way that lymph nodes filter lymph. It gets rid of damaged and old red blood cells, recycles their iron, and helps fight infections. It can also be used as a blood bank in case of an emergency. Your circulatory system and the other organ systems in your body work together in a close and complicated way. Your heart rate and blood pressure are controlled by your nervous system, which changes its response to your body's needs. Specialized receptors in your heart and blood vessels constantly check the pressure and send signals to your brain, which changes the size of your heart and blood vessels as needed. Your endocrine system sends hormonal messages through your blood. Hormones made in your brain, thyroid, adrenal glands, and other organs travel through your blood to get to the tissues they need to work on. The hormones that come from the thyroid control your metabolism, which affects how fast your heart beats and how much oxygen your tissues use. Your circulatory system and your respiratory system work together to move gases around. Your blood's levels of carbon dioxide and oxygen automatically change the speed and depth of your breathing. When you work out and make more carbon dioxide, your body automatically breathes faster and deeper to get rid of the extra and take in more oxygen. Circulation is important for your digestive system because it moves nutrients that have been absorbed around your body. After you eat, your digestive organs get more blood flow to help them digest and absorb food. The hepatic portal system makes sure that nutrients that your intestines absorb go through your liver first, where they can be processed and stored as needed. Your circulatory and urinary systems work together to keep the right amount of fluids in your body and get rid of waste. Your kidneys are always checking the makeup of your blood and changing how they filter and reabsorb it to keep the right levels of different substances. The kidneys also make hormones that help control blood pressure and the production of red blood cells. Your skin even helps your circulatory system keep your body at the right temperature. Depending on what your body needs, blood flow to your skin can change a lot. When it's hot outside, or when you work out, blood flow to the skin can go up by more than 10 times to help cool it down. When it's cold, blood flow to the skin slows down to keep heat in the important organs. It's almost poetic that the same blood that brings oxygen to your brain cells while you think about these words also brought the nutrients that made those brain cells in the first place. The iron in your hemoglobin may have been forged in the heart of a star billions of years ago. It now helps keep you alive by moving oxygen through your body. This view of the universe reminds us that we are all connected, not just to each other, but also to the universe itself. When stars died, they spread out into space all of the calcium in your bones, the phosphorus in your DNA, and the oxygen you breathe. You are literally made of star stuff, and your blood vessels are the way this cosmic material moves through you. Your blood also links you to your evolutionary history. The amount of salt in your blood is similar to that in ancient seas, which reminds us of where we came from. Many of the proteins in your blood are like those in other vertebrates, which shows that we all evolved from the same ancestors. Your heart has 4 chambers, and your pulmonary and systemic circulations are separate. This basic design is the same as that of other mammals and has been improved over millions of years of evolution. The story of circulation is also a story of finding things out. For most of history, people didn't know how blood flowed through the body. Doctors in ancient times thought that tissues ate blood and that it had to be replaced all the time. William Harvey didn't correctly describe how blood flows until 1628. He showed that blood flows in a closed loop and that the same blood is recycled through the body over and over again. Harvey's discovery changed medicine and biology forever. It showed that the body worked like a machine and could be studied and understood by carefully watching and testing things. This mechanistic view of the body was the basis for modern medicine and physiology. Later discoveries showed how blood vessels are made up of tiny parts, how the lymphatic system works, and how circulation is controlled by a number of different systems. Scientists could see capillaries for the first time and watch blood cells move through them thanks to the microscope. New ways to measure blood pressure, listen to heart sounds, and see blood vessels have given us new ways to learn about heart health and disease. We can see your circulatory system in amazing detail today, thanks to advanced imaging methods. Echocardiography uses sound waves to make pictures of your heart that move. Angiography uses X-rays and contrast dyes to show blood vessels. MRI can show how blood flows through vessels without having to do any surgery. These tools let doctors find and treat heart problems with an accuracy that has never been seen before. More and more research is showing us new things about how the heart works. Researchers have found that blood vessels change their own size by making things like nitric oxide. They found out that inflammation is a big part of how atherosclerosis forms. They found genes that change the risk of heart disease and are working on new treatments based on this genetic knowledge. Regenerative medicine has the potential to fix damaged hearts and blood vessels. Scientists are trying to grow new heart muscle from stem cells, make fake blood vessels out of materials that break down over time, and even build mechanical hearts that could permanently replace failing natural hearts. As you lie here tonight and listen to these words, your heart is beating steadily in your chest. Your blood is flowing quietly through miles of vessels, and millions of cells are exchanging information every second. It's a symphony of life going on inside you, a work of biological engineering that keeps going whether you're awake or asleep, thinking about it or not. One of the most reliable things in your life is the quiet flow of your blood. It started before you were born, when your tiny heart started beating about 3 weeks into your pregnancy. It has stayed with you through every joy and sorrow, every victory and failure, and every moment of love and loss. It will go on until the end of your life, when your heart stops beating and the great circulation comes to a stop. Your circulatory system has helped you grow and develop since you were a child. It has changed to meet the needs of adolescence, when growth spurts required more blood flow to tissues that were growing quickly. It has helped you through the activities and stresses of being an adult, changing how it works to meet your needs. Your circulation might tell stories about late nights when it worked harder to keep you awake, stressful times when it raced with worry, and happy times when it carried the hormones of happiness through your body. It might talk about the food it has moved, the toxins it has helped get rid of, and the infections it has helped fight. Your blood has been a silent witness to your life, holding the chemical traces of every meal you've eaten, every breath you've taken, and every emotion you've felt. It has been the way your body has talked to itself, the river that has linked every cell to every other cell. As you get ready for bed tonight, take a moment to think about how amazing this system is. Put your hand over your heart and feel how steady it is. This rhythm has been with you since you were a baby, and it will always be with you. You can feel the pulse in your wrist, which is proof that pressure waves are moving through your arteries with each heartbeat. As you rest, billions of red blood cells are traveling through your body, carrying the oxygen that will fuel your dreams. Each of these cells is like a tiny delivery truck, carrying important cargo along ancient routes that have been mapped out and improved over millions of years of evolution. Think about how simple and elegant the system is. A pump that fits in your hand can move fluid through thousands of miles of tubing and reach every part of your body. Consider how perfectly your heart, blood vessels, lungs, and kidneys all work together to keep you alive. Your circulatory system doesn't ask anything of your mind, but it gives everything. It works while you sleep, work, laugh, cry, and love. It is the quiet protector of your life, the loyal servant who never complains, never hits you, and never asks for credit for all the work it does. Your circulatory system is a great example of the qualities we all want to have as people: reliability, dedication, flexibility, and serving others without expecting anything in return. It keeps working without praise or recognition, not for external rewards, but because it has to keep living. Your circulatory system is getting ready for the changes that come with sleep as you start to drift off. Your heart rate will slow down when your parasympathetic nervous system takes over. As your blood vessels relax, your blood pressure will go down. As your digestive organs and liver work to process the day's events, blood flow will change. Less blood will go to your muscles, and more will go to your digestive organs and liver. Your circulatory system will help with important repair and restoration processes while you sleep. When you sleep deeply, your body releases growth hormone. This hormone travels through your blood to tissues all over your body, helping them heal and grow. Your liver will work all night to get rid of toxins and metabolic waste. Your kidneys will keep filtering your blood to keep the chemicals in it in balance. During sleep, your immune system is also busy. White blood cells patrol your circulation more actively than when you are awake. When you sleep, your body fights infections best. Wounds heal fastest, and memories are stored and made stronger. Your circulation is what brings nutrients to your body, takes away waste, and keeps everything in your body working together. Your circulation will help you have the dreams you have tonight. The neurons in your brain that make up the rich tapestry of dream images need a steady supply of glucose and oxygen, which blood flow provides even while you sleep. The neurotransmitters that send messages between brain cells move short distances through the fluid between cells, but they need circulation to get the materials they need to make them. Your circulatory system will be ready to help you get through another day of activity when you wake up tomorrow. As you wake up, blood flow that was redirected while you were sleeping will go back to your muscles. Your heart rate will rise to meet the needs of waking life. Stress hormones that keep you awake will move through your blood to the organs they need to reach. Sleep well tonight, knowing that your amazing circulatory system will keep doing its job while you sleep, getting your body ready for tomorrow's adventures and keeping the delicate balance that keeps you alive and healthy. Your blood will have delivered fresh nutrients to every cell, carried away the waste products of the day's activities, and kept the chemical balance that lets you think, feel, and be. You'll wake up feeling refreshed. Blood moving through your body is more than just a mechanical process. It's what keeps you alive. It links all of your parts together, making a single whole out of billions of cells. Your circulation is like a thread that holds your life together. It is like a river that flows through your body. As you drift off to sleep, keep in mind that you are part of a chain of circulation that has been going on since the first complex life forms on Earth. Hundreds of millions of years ago, The first hearts beat and set the pattern for your heart to follow tonight. You have the knowledge of many generations inside you. The experience of evolution is written into the very structure of your cells and organs. Your blood flow links you to both your past and your future. The nutrients that are in your blood right now will help make new cells tomorrow. The waste products that are being taken away will make room for new growth and renewal. Your circulatory system protects your current self and shapes your future self. Good night, and thank you for coming along on this calm trip through the quiet highways of your circulatory system. Until we meet again to peacefully explore the wonders inside you, sleep well knowing that your blood flows on, carrying with it the essence of life itself. Your circulation continues its ancient dance through the night, which is a quiet miracle.